Hello everyone, welcome to the National 5 um, course videos. This one covering the trigonometry unit. Let's have a little look at what we're going to do today. So far in the unit we have covered quite a lot of these. We've done the area of a triangle, we've found the length of a side in the triangle using the sine rule, found an angle using the sine rule. Remember, that's where you turn the sine rule upside down. Um, We've then found a side using the cosine rule, and the one that we're going to look at today in this video is this one here. I can calculate the size of an angle in a triangle using the cosine rule. Now, let's have a little look at why. Right, so let's say we were presented with a question here. Calculate the size of the angle at A. Well, what information have we got? Well, notably with this triangle, something a bit different that we've had with most of the questions that you've tried so far through this unit is that we know the lengths of all three sides. They're all there. We don't know the lengths of any, or sorry, we don't know the sizes of any of the angles. So there's a clear difference with this question from the other ones. Let's have a wee look at what strategies we know at the minute. Let's have a little look at the sine rule for calculating an angle. So in this case, it would be um, sine A over A equal to sine B over B equal to sine C over C. Right. Well, what do we know? Well, we know all three sides. We're trying to calculate the angle at A, but we don't know the angle at B and we don't know the angle at C, and we've no reliable way of working that out. We can't use any angle properties because we just simply don't know any of the angles. This triangle is also scaling. None of the sides are the same size, so there's no sort of symmetry or sort of trickery that we can pull that way. So there's really nothing further we can do with that, because without one of the angles, either B or C, without either of those, then we don't have a complete pair with 3 out of the 4 sides, 3 out of the 4 bits of information unknown. It just doesn't exist. So, well, okay, sine rule's a bust. Let's try the cosine rule. Well, okay, so you get a squared equals b squared plus c squared, take away 2bc cos of a. Right, okay. But that formula is for calculating a side, not for calculating an angle. So that's not really much use to us either. So the reason why I think it's really important that you see that is because further down the line, you're going to try trigonometry questions where you won't be told, by the way, this is a cosine rule question, by the way, this is a sine rule question, and so on. You won't be told. You'll have to sort of come up with the right strategy yourself. So I guess like what I'm showing here is a useful way of ruling out strategies. If you genuinely don't know and you try a strategy, like you try the sine rule, and there's no way of getting that to work. You try the cosine rule, well, there's no way of getting that to work. So it must be something else. Um, in this lesson, we are going to learn all about what that something else is. So let's have a little look at the cosine rule in a wee bit closer detail. You can forget the sine rule, that's not used to it. But if you look at this formula, cos of A would be a very useful thing to work out. Because if I know what the cosine of this angle at A is, well, I can take the inverse cosine of it and come up with the angle. So do I know enough of the rest of the information then? Well, I know this is just the length of side A, that's 50. I know this, that's just the length of side B, that's 22. I know this, that's just the length of side C, that's 28. Remember, opposite sides. And, well, 2 is just 2, I know B and I know C. So I actually know, if you look at the cosine rule in greater detail, I know all of the information except the final piece. So if you rearrange the formula here, right, then what you end up with is a formula for an alternative form of the cosine rule. I'm going to show you the proof. I'm going to show you the next couple of lines of working. You will never need to produce these lines of work, right? At National 5 level, you will never need to produce this. And in fact, the formula that I'm about to get to is on the formula sheet. But I know some of you are out there who will quite want to see it, and this one isn't too difficult to get to, so I'm quite happy to show you. So, as I say, I'm going to show you the proof just now, but ultimately you don't need to know the proof, um, so don't worry too much about it if you don't really understand it. Essentially what I'm going to do, I'm just going to change pen colour here and put a kind of box around this bit. Essentially that is just one algebraic term, and what I'm going to do is just add that to both sides. So I'm going to have a squared plus 2bc cos a equal to b squared plus c squared. And then a squared doesn't really want that there, so I'm going to take it away from both sides. So we get 2bc cos a equal to b squared plus c squared, take away a squared. And then I want cos a really on its own, I want the formula to work out the cos of a. So this bit here I'm going to have to divide by this and come up with cos of a equals b squared plus c squared, take away a squared, all over 2bc. And that is the alternative form of the cosine. Okay, so I'm going to change page in a wee second and give you a proper note on this. This was just a bit of a kind of preamble, a bit of an introduction. So remember, you don't need to produce any of this proof, but I know for a lot of you it will be for interest. Right, so here's the proper note. Using the cosine rule to find a side or angle. What I've noticed in many of the pictures of your work that I've seen, you have been very good at note taking through this. So you might want to pause the video and take a wee note of this. So I suggest you maybe take a wee note from there, the diagram for instance, the heading and the sentence at the bottom. So if you want to pause the video, copy that down. Right, the last thing I'm going to talk about before, I'm just going to talk through this actually. The cosine rule says for a triangle with sides A, B and C with angles capital A, capital B and capital C, the cosine rule for an angle states, and we've got this one here, which is the one I produced on the last page. This is the one that's also on the formula sheet. Okay, these two, cos B and cos C, are just alternate forms. So this is how you would write the cosine rule, like this second one here. This is how you would write the cosine rule if you were calculating the angle at B. Yeah, you would do the other two sides squared and added, take away, notice these letters match, same there, right? Take away the square of the side opposite the angle you're trying to work out, divided by, notice these two letters always match these two letters, AB, A squared and B squared, BC, B squared and C squared. So you see the kind of pattern that emerges there, alrighty? So you can use this last sentence is really, really important. You can use this formula to find any angle in a triangle, so long as you know the lengths of all three sides. So let's have a look at an example. Find the size of the unknown angle x to one decimal place. Right, well, the unknown angle x is the angle at A. I know all three sides, so I'm going to use the cosine rule for the angle at A. Cos A squared at B squared. Take away, whoops, got that wrong. See, it's dead easy to do. B squared plus C squared, take away A squared over 2bc. Sub in the numbers, right? So cos of A equals b's 50, 50 squared, plus 47 squared, take away 25 squared, all divided by, so that's all divided by 2 times b times c. Now, the beauty of the modern calculator these days is that piece of working can usually be inputted into the calculator all in one go. If you use the fraction button, there's no need for brackets. I know certainly when I do it with my black Casio one, no need for brackets, fraction button, just type it in exactly as it is and you will get the correct next line. Again, if you're having issues with your calculator, please let me know. And what I can do is I can help you out if you let me know your calculator's having issues. Alright. When you put that all into the calculator, you will be told that the cos of A is equal to 0.868. And then a whole string of numbers after that. Don't clear the screen. What you want to do is you want to write down that that's what you've got. Clearly that is not the size of that angle, that is the cosine of that angle. So the angle at A is the inverse cosine of 0.868, and the inverse cosine of that comes to 29.7 degrees to one decimal place. And it's that easy. Let's look at another one. This time it's triangle PQR, and we've to find the size of angle PQR. Well, angle PQR is this one here, the angle at Q. So let's write out the cosine rule for finding Q. Cos Q equals, now remember it's the two sides beside it squared and added, so will be r squared and p squared that we're going to use. So I'll go p squared add r squared, take away q squared over 2pr, and that's it written out for cos q. Let's find cos q now. 15 squared plus 17 squared, take away 25 squared over 2 times 15 times 17. Okay, again, run all that through the calculator exactly as it is, and this time you'll get a negative number. You will get negative 0.217. Now, the problem, there's not a problem with this. Don't be put off by the fact that it's a negative. All you need to do is take the inverse cosine of that. So inverse cos, don't clear the screen, negative 0.217 . So remember, like on your calculator, that's inverse cos, it's usually the answer key that you're putting in. So inverse cos negative 0.217, and you get 102.6 degrees. Right. Now, there's a handy tip here that can help you sort of give some common sense to your answer, check whether you've got it right or not. Um, it's not that obvious from the diagram that Q would be obtuse, right? In fact, arguably in the diagram, it probably doesn't look like that. The triangle maybe shouldn't be as tall. So never really go by the diagram. But a couple of things you do notice about this. The angle at Q is opposite the largest side, so it's bound to be the biggest angle. So it may well be, although not exclusively, but it may well be obtuse. The other thing to look for is that for when you're using this method, for any answer, if it's an obtuse angle, this value here will always be negative. So always negative for obtuse angles. That's why in the last one, this number was positive. Remember, it was positive 0.868. Positive numbers give acute angles. Negative numbers at that stage give you obtuse angles. So there are a variety of ways there that you can use to kind of keep yourself right. You're not told in the question it's obtuse, but you might work on the assumption that it's going to be. It's opposite the biggest side, and you're looking for a negative number in that line. So that's all I've got for you in this video. Well done with your work so far. I'm just going to give you a real list of questions to do from your textbooks. Let's have a look at exercise 18.5. And I want you to do questions 2 through to 7. Right? You don't need to do the first one. It's one of the ones that's sort of stepped out and guides you through it. And you can do it if you want, but we wouldn't normally do that one. So questions 2 to 7 from that exercise, please. So thanks very much for listening. Again, as always, if you have any questions, please let me know.